Good evening, everyone. My name is Jansen Jones. I'm a virtualization MVP. I'm from Indiana University.
And my name is Nathan Lesnowski. I'm a virtualization MVP as well, and I'm from Milwaukee, Wisconsin.
Thanks. So glad you came out to this session here. I know there's not a lot of Hyper-V sessions this week since this is primarily a System Center conference. But as much as excited as we are about System Center 2012, we're also excited about Hyper-V, obviously what System Center manages well, in addition to those other hypervisors. And we're going to talk to you today about tips and tricks around Hyper-V. In the title of the session, I believe it still said Windows 2008 R2, Hyper-V tips and tricks. We're going to talk about some Windows 8 today, just because we would be remiss if we didn't tell you about all of the best practices and considerations that pertain to R2 don't necessarily pertain in Win 8. And so we're going to try and point out all of the things that are different in Windows 8, as well as tell you a little bit about some of the new features that are coming in Windows 8, because really just Hyper-V in Windows 8 at this point is extremely exciting, and I've been using it for a few months now, and very excited to the things that's coming to pass. So as we look at the slides here, these are just sort of the bullet points that we're going to run down today and discuss where those come in R2 as well as where those come in Windows 8. And if you have questions along the way, feel free to ask. We'll also have a Q&A session at the end, depending on how long we're going. We've also got some other MVPs in the audience around clustering and Hyper-V that can hop in, especially when we talk about maybe a more complex deployment scenario. Before we get started, I wanted to gauge the audience real quick. How many are currently managing a Windows 2008 R2 Hyper-V infrastructure in their environment? Okay. How many have tested Windows 8 and have been running a Windows 8 Hyper-V, at least in test or lab or something? Okay, great. So with that, we'll go ahead and let Nathan get started on our first topic.
All right. Well, we're going to talk a little bit about deployment structure. One of the things that I do as my kind of day-to-day job is working with customers to design and implement Hyper-V infrastructures. And that goes for companies that are doing extreme scalability, extreme consolidation to the tune of 175 to 1 from a server to virtualization ratio. We also have some very small deployments as well for branch offices, for distributed deployments. And I want to talk a little bit about how you go about defining what those things are going to look like. And also we're going to talk about how that changed a little bit in Windows 8. So the first thing we want to touch on is what are the two principal deployment options. The first would be what we'd call a standalone deployment. It's used principally for branch offices. Where we've seen a lot of success with that type of implementation is where a company has a large number of distributed branch offices. And they are running maybe a domain controller out there, they're running an SCCM server out there, they're running a file server out there, they're running some sort of utility box out there. And these are these physical servers today, and they want to try to consolidate that. So what we find is that we're able to deploy single standalone Hyper-V hosts out to branch offices, or clustered Hyper-V hosts with SAS storage out to branch offices that serve the domain controller functions, that serve the file server functions, SCCM, and all other distribution occurring at that branch. Now, what's really important is when you're dealing with those branch offices, and especially virtualized domain controllers, you follow some of the best practices that we're going to talk a little bit about later regarding virtualization of DCs. That's specifically because of the rollback issues that come along with things like snapshotting and backups, and also with ensuring you have the correct startup intervals set for domain controllers versus regular servers. So that's something that we can certainly talk about. But we found that this is a great solution for those smaller branches. Also, we could talk a little bit about larger clustered implementations. Clustered implementations kind of come in two principal sizes. You might say expanded large capacity single implementation versus smaller modular clustered implementations. This sort of depends upon your needs as an organization. There's some costs and benefits around these. First is that for live migration within the nodes, that larger singular implementation is going to provide that asset, right? So if you have a 10-node cluster, for example, and you're running 192 gig of RAM on each one, or 256 gig of RAM, whatever that happens to be, you're going to be able to live migrate between all those nodes. You're going to have one single opportunity to be able to have failover within that cluster, and your process of patching and updating that cluster is a little bit more straightforward. However, you don't necessarily gain some of the isolation benefits that come along with having more separated clusters. What we find is that a lot of companies tend to go with these 4, 5, 6 node clusters that are made up of a variety of blade servers or a variety of smaller modular systems. And the asset behind that is that they're able to isolate their workloads and grow a little bit more, grow in a way that probably aligns with their purchase model. It also allows them to structure their Hyper-V environments in terms of self-contained groups. So we found that to be a nice little asset for those types of companies. We've also had a little bit of an argument between, do we go with larger servers or do we go with smaller modular servers? One of the things that we found in our implementations has been that a lot of companies like to grow in these sort of 8 to 10K bumps because they can acquire that hardware much more easily than they can acquire those 20 or 30K very, very large hosts. Now, the 175 to 1 type of consolidation ratios that I was talking about, those are very, very large servers, right? We're talking about 512 gig of RAM, a terabyte of RAM, lots of RAM on these servers where we're doing a lot of consolidation on these boxes. And that puts a lot of work in one sort of wheelhouse there, right? You have a lot of points of failure inside of that one single server. But the asset of it is that you can take a lot of virtual machines, you can put them all in one box. So one of the things that we can certainly talk about in your Q&A sessions is let's bring up some of those specific usage scenarios where you guys want to talk about which direction you think would be best practice to go in. We've seen a lot of success with those very large servers. We've also seen a lot of success with the modular blade infrastructures, such as the Cisco UCSs or the HP products or the Dell products. Those have all served us very well. So we can absolutely talk about that as well. When we're talking about the cloud hardware providers, they're doing some things that are very, very interesting. I would encourage you to go and look at what Cisco, HP, and Dell are doing with their blade systems. We found that we've been able to achieve some really awesome things with those. Particularly, we just did a project with some of the Cisco and some of the Dell ones where they're literally virtualizing the hardware components underneath the stack, and that allows for the teaming and for the hardware positioning to the servers to be much more flexible in terms of how the Hyper-V environment is actually going to use it. So we found that to be a really nice advantage as well. So the key thing I want to kind of mention here is that Hyper-V is a platform where we've seen success with very, very large clusters all the way down to very modular clusters that are built on these sort of 8 to 10K bumps. So as you guys come up with some questions, we'd love to be able to address some of those. Now, what happens in 2012? In 2012, what we found and what we've been very happy to see is that the maximum size of a cluster has been drastically increased. So we have 32 node possibility here inside of a very large cluster, which means that we have extreme scalability inside of our cluster for high availability. It also allows for us to have multi-tenancy inside of the context of that cluster, so that's something that's been a big asset to us as well. And then also massive live migrations. Some of my colleagues have been testing 60, 70 live migrations all occurring at the same time between cluster nodes. Pretty awesome stuff, totally utilizing 20 gig connections between these systems. Also, something that you can take advantage of is clusters with SMB storage. So right now, your clusters are limited to using cluster disks, right? So you have a SAN that's associated with your cluster that's either on SAS storage or SATA storage or on a fiber channel or iSCSI, and that's presented to your cluster as a shared disk. In 2012, you have the opportunity to be able to use SMB storage over SMB 2.2, and that is extremely fast. It's actually very comparable performance to iSCSI, and that's something that you can look to use for your moderate workloads. You can use it with your VDI systems. You can use it with your lab systems. There's a lot of opportunities to be able to take advantage of that, where maybe your enterprise storage isn't appropriate for that use. That's something that's going to modify some of the topology choices that we had been choosing in the past. Also, something that's been a big benefit for us is when you go with more isolated clusters, the mobility benefits in Windows 2012 allow us to be able to live migrate between those clusters. So although the virtual machine isn't going to automatically fail over between the isolated clusters, we do get that mobility now, whereas in the past we really didn't have that. So if you had two separate individual clusters in the past, you couldn't live migrate between those clusters, right? You had to move it between the clusters through a storage motion. In this case, you have the opportunity to be able to live migrate between those clusters if you felt like one of those clusters was becoming overtaxed and you wanted to move those resources to the other cluster. So that takes away some of the negatives of having distributed clusters and isolating those workloads. So that's something that we're really happy about. And in our testing environments in production, we've seen that that's been something that's been very valuable. All right, Jansen?
So let's just take a few minutes and discuss best practices around config. Just taking a box, racking it, and starting to use Hyper-V. I know we saw by a show of hands, we have a lot of people out there using Hyper-V today. For those that haven't There's a few things that you want to know right when you go to start setting up the machine. The first thing is that when you're setting up a Hyper-V workload, it's not necessarily going to be the standard Windows setup that you follow on another workload. And the primary reason for that is because some of the hot fixes and some of the drivers that you normally expect just sort of work out of the box don't necessarily apply within Hyper-V. We'll start it with C-states, first of all. How many of you out there, show of hands, are familiar with C-states? Okay, so a few. C-states are basically a way to allow the piece of equipment that you're using to save energy by going into different levels of sleep or different levels of core management. So let's say you've got a 32 processor machine and it only needs to run at half capacity. Through various levels of sleep, various levels of C-states, and various levels of core parking, the machine is able to save energy. However, there's always, since the last few years when this has been out, there's always little catches that you see here and there. This even happens on a desktop operating system. This isn't a server-specific item, but there are cases where when these things are enabled in the BIOS to do maximum power management, you can actually see performance suffer. You can see performance suffer at the network layer. For example, there are cases of where live migrations run slower while you have C-states enabled. You can see other perf issues, and most of those perf issues historically now have been fixed over time through various hotfixes, but we've actually seen some new issues in Windows 8 as well around C-states and some of the edge cases that you can hit with it. So the general best practice that we follow is it's best to try and maximize your power savings by consolidating your workloads onto as few machines as you can run on, and then let those things run at full throttle, as opposed to pushing this out over several machines and trying to gain the power over each of those individual machines. So your mileage may vary there, but that's one thing that I would want to encourage you to look at if you ever do come across a machine where you think perf's just not quite right. One of the first general things we try to do is go into the BIOS and disable C-states, and disable C3 specifically is another thing you'll see in that general area. Secondly, hotfixes. With Hyper-V and with Hyper-V clustering specifically, not all of the hotfixes that you're going to need are going to come through Windows Update. Not sure if you're familiar with GDRs and LDRs and QFEs, but the general idea is that some hotfixes are distributed to the general masses, the GDRs, through Windows Update, and some hotfixes are gauged to be more limited in scope of the things that they cover, and maybe not everyone will hit a given issue, and those are generally released sometimes first and then sometimes they follow on, but sometimes they're only released as an LDR, a limited distribution release that will later be rolled into a later service pack or integrated somewhere else. So there's a few of those that exist in both Hyper-V and within clustering. The top link on this slide is actually the clustering hotfix list, and the second link is the Hyper-V hotfix list. But the important thing to take away from this is that there are specific fixes that you might require in your environment that you're not going to get today through Windows Update, but that may dramatically help you or save you time down the road. So I would encourage you, when these systems are going into production, to check those lists or just do a web search for R2SP1 post hotfixes, Hyper-V clustering, etc. The last thing I want to mention is firmware BIOS driver updates. Again, on a standard workload, if you're just going to run it as a file or print server, that's not necessarily always as big of a deal, but especially what we found around Hyper-V, and especially with networking cards, is that there's a lot of special stuff that's going on with network cards when Hyper-V comes into play, whether it's with RSS or with offload or with things that are happening in the vNICs. We've seen issues, especially around 10 gigabit drivers and the technologies that are coming, that you generally want to steer clear of the inbox drivers. We saw that in Windows 2008 R2, and we also have seen that so far in our testing in Windows 8. And the second thing with that is HBAs. We've especially seen through Windows 8, we've seen some HBA driver issues in box in our early beta testing. Those drivers get better as we progress from beta to RC to RTM, but it's still valuable over time to go through and actually to see what the vendor has, specifically around HBAs and NICs. Those are the two things that I would point out above and beyond other drivers, but it's generally good practice to check all of those.
We find that particularly true with iSCSI and other HBA drivers, such that when Dell or HP or IBM are testing those drivers against their servers, it's at a different interval than, say, Broadcom or Intel or any of the other vendors are coming out with their new driver versions. So you need to be very cautious about applying the latest driver version to an existing functioning environment until it's been fully tested by the manufacturer team that makes the server or by the Hyper-V team. And I think there's a question.
Yeah, just a quick question on the hot fixes. Is there any downside to going out and just applying everything to the box?
So the question was, is there a downside to just applying all hot fixes straight to the box? I think Microsoft would probably tell you the reason that an LDR fix is an LDR fix is because it hasn't gone through the same level of testing that another hotfix might go through, and that's why it's in that state, which is why you usually go to the web page and hit, I want this hotfix, download it, and sign your name. But I have not ever seen, in this case, an issue with any of these hotfixes causing any problems. And in our environment, when those fixes come out, we read the text and say, is that a case we could ever hit? Whether it's a case around backup. Some of these hotfixes deal specifically with backup improvements or clustered backup improvements. Some have to do with Hyper-V networking under load. So generally, if you read the hotfix, you could say, is that something I'm going to hit? If you're never going to use a third-party backup, you might not necessarily put on the third-party hotfix for backup. But,
yeah, I can echo that too. We've done probably well over 200 deployments of Hyper-V. And in our deployment checklist that we follow, we go out and we apply every single one of those updates. We have them all downloaded ahead of time. We just run through them.
So you do 100% apply in either case. So yeah, I've not seen an issue with applying any of those hotfixes. But again, especially when they come through over time, because these happen unless you're watching the site over time. New ones are going to come out. So if you see 3 come out in August, then yeah, obviously we'll just go through and read those 3 because they're not going to come through Windows Update. So the key takeaway is you need to watch these lists and make sure stuff's coming out that's not just in Windows Update, especially around Hyper-V clusters.
So I'm hearing that it's okay to apply those hotfixes, but for the firmware, BIOS, and driver updates, use caution and make sure that they're tested by the manufacturer and the Hyper-V.
Yes, especially firmware. If you apply firmware updates to your Hyper-V hosts, what will happen is it will cause your NICs to redetect. And that's really bad because they all get re-registered, especially on iSCSI, right? So it re-registers all those NICs. They all show up as new NICs. And then it has to go out and you have to reconfigure all your storage connections again. So firmware is something that you need to do under a very specific change window. It's not something you should just do one night and not be prepared to be able to make sure that your systems are performing properly.
So yeah, so I'll echo that the changes there around updating BIOS and firmware can definitely wipe NIC settings, and that was actually a slide that we had in here, but I took back out. I guess I'll re-mention that. It's important to document your NIC settings. That's a given. Someone would mock you and say you should always document your NIC settings. But when you go through and apply the firmware update and then find that you have no NICs anymore, especially if there are 12 NICs in the system, and you don't have a PowerShell script that's going to go through and reapply those 12 using NetSH or something, you're going to have another 30 minutes of going back and reconfiguring that. That's the big gotcha, especially around NICs. But that being said, our experience is that when we're about to deploy a new machine, we always make sure that we put the new driver updates on, and after that we don't apply any more driver updates unless we hit an issue. But the in-box ones, we can pretty much guarantee that it's going to be a matter of time before we hit that issue. Okay, so we actually in this case don't have a Windows 2012 slide around best practices, how they've changed, because all these still apply. The driver issues still apply. There aren't the hot fixes are going to be coming over time right now because we're still very early in releases. But again, as I mentioned with C-States, it still applies. So one item of note I just wanted to mention, this one isn't necessarily something that you want to do unless it applies to you specifically. And the people that it primarily applies to, the person that it primarily applies to would be one that has a small C drive. So when you buy your servers, depending on what you've got on your C drive, if you only have a 64 gig C drive, for example, but say you have 64 gigs of RAM, you're not going to have much space left on your machine beyond what the page file already has. So let's say you wanted to put stuff on your C drive to just do an ISO file to mount to a guest, something like that. You're not going to have any room. So one of the things you can do if you end up on one of these machines with very limited storage that you need some space for is you can actually bring down the size of that Hyper-V parent page file. So there are primary two reasons to have a parent page file. One of those is to do crash dump. So if you need to do a kernel dump, you're looking at no more than 4 gigs of RAM. So what you can generally do, oh, and of course you're going to need memory just for the parent machine. If it needs to do any sort of paging, you're not going to use more than a couple gigs. So what we've generally done in all of our environments on any of our older, especially our older blades, because we ran a ton of workloads on older 3 to 4 year old blades that all had, say, 64 gig hard drives, is we'll go in and change that page file to 8 gigs, and that gives us back all of that space on the C drive to do things like mount some specific ISOs that we use over and over, or a couple gold VHDs that we want to have really fast access to. In fact, some of our deployment scripts, we actually keep gold VHDs on the C drive and dump those over quickly onto cluster storage as part of just a really fast way to ramp up a bunch of VMs. And that's a way to give us that space. Again, this isn't something that you'll see as listed as Microsoft guidance, but I've never seen an issue with it. And if you have zero space on your C drive, because especially if you have a lot of memory and the page file is eating the entire thing, that's something you can do. Oh, we did actually have a 2012. So same patching, same driver, same everything else. The one main thing that's different around 2012 that I would say is that historically server core has been extremely painful. If anyone's tried to deploy server core, what you'll find is a few small things that you need to do, changes that you need to make are very difficult to make unless you go and download a third-party tool, like the core configuration tool. I think that's the CCC. There's a couple of different packages out there that will allow you to do some management of your server core device. But as time has gone on and more teams within Microsoft have embraced PowerShell commandlets, many of the things that were difficult to do in Windows 2008 R2 can now be done via PowerShell in Windows 2012, whether that's doing things with iSCSI, with MPIO, with Hyper-V, with failover clustering. So the main thing that I would say that you would want to take away is if you've always scorned server core in the past, this is the time to go back and look at it. We, through our R2 implementations, have always gone back to full server just because it was too painful to get back and do the things that we needed to do. In Windows 2012, we've made the commitment to go back to full server core implementations across all Hyper-V clustered workloads. And so the one other added benefit that you've got in Windows 2012 is that you can actually roll back and forth between server core and full, just as you're adding a Windows feature, adding a role. I guess they call them features. They used to be called roles. We won't go down that road. But you can add the Windows full server role through a commandlet. So if you're on server core and you hit just some weird case that I need to go do something, either I need to throw a GUI on to do some sort of debugging or troubleshooting, or there's some way that I know how to do something in the GUI that I just can't figure out how to script, you can actually go back in, add the full server on, make your change, and come back. Obviously, you don't want to do that very often because that takes some time, but it's an option. So going forward, you should be able to look at running Hyper-V on server core much easier than you've ever been able to historically do. The last thing I'll mention in 2012 that's new is cluster-aware updating. There's a lot of things that made managing Hyper-V clusters take a bit more time historically when it came to patch time, is that you had to manually go in. Now, if you had VMM, you could go into maintenance mode and orchestrate a lot more of that. But now in box in Windows 2012, you have the ability through cluster-aware updating to just go to my cluster that's linked with WSUS and say, update my cluster. And it will automatically drain all of the virtual machines, all of the cluster shared volumes off of a node, run its patches, restart that machine, bring it back up, failed machines back, and actually roll through your entire cluster. So when it comes time to patch your hosts now, the new live migration technologies, the concurrent live migration, in addition to this, mean that really an admin can come in at 5 a.m. and hit that button potentially in a couple hours with 0 other clicks, have a totally updated Hyper-V cluster. You were taking?
Yep, yeah. Awesome. All right, one of the things that we've done quite a bit of work with has been dynamic memory. Dynamic memory is an awesome feature. It's something that we've been able to gain significant consolidation from. And the primary workloads where we've seen it used have been VDI, for your general use server, such as a web server, file server, a application server that's supporting dynamic memory in some way, or burstable workloads that we need to be able to allow to expand and then contract. Some of the things that you need to make sure you're aware of is that there is a hotfix required for Windows 2008 Standard and Web. So if you don't have that deployed, dynamic memory isn't just going to start working on those servers until you make sure that that hotfix is deployed on those servers. Also, what a lot of people don't know is that SQL Standard does not support hot add memory. So SQL Standard does require fixed memory because it doesn't allow the memory to expand and contract. What's going to happen is it'll look like it's functioning properly. You'll enable dynamic memory. You'll set it up with the startup memory. You'll turn it on. It'll look like it's working. Then you'll get these very bizarre results by SQL being unable to deal with dynamic memory. And you'll start to have some crashing, right? So you need to make sure that if you're using SQL Standard, that you're using fixed memory. Now, if you're using Enterprise Edition or Data Center Edition, it absolutely supports dynamic memory. So we use that all the time in our data centers. We use dynamic memory with our SQL Enterprise Edition implementations because that allows for us to be able to burst, to be able to deal with our demos, to be able to deal with high capacity needs or high performance needs that we might have. So one of the things that don't work really well with DM, Exchange is a particular one, because Exchange always tries to get as much memory as it can, right? So Exchange is just going to keep eating and eating memory. So it's not a great candidate for dynamic memory. We tend to use fixed memory for Exchange. Also, Java and Oracle don't tend to like dynamic memory. Also, something you should be aware of is that there are minimum memory requirements. So you typically end up at 512. But what I've found is that certain workloads, like remote desktop services, for example, if you try to go all the way down to the most minimum workload, most minimum RAM possible, your users are going to start to experience some performance problems until the server sees the impetus to do the hot add memory operation. So what we found is a way to avoid that is by having the startup memory significantly higher. That would allow it to expand and contract, but it gives it more startup memory right from the get-go. Also, increasing the buffer for those servers tends to be a good option. Finally, make sure you also configure your host reserve appropriately so your server is not starved of its memory. Your host server should always have at minimum 512 megabytes of RAM. That's very important. We tend to reserve a gig just to make sure we have it. Now, what has changed in Windows 2012? We have a now buffer on startup. And we also have minimum memory versus startup memory. What this essentially allows it to do is to start the virtual machines even when the host is starved of the memory necessary to start those virtual machines. So in 2012, they haven't made a ton of changes to dynamic memory, but they certainly addressed some of the startup memory issues that we had in R2.
One thing I'd like to add about, for example, something like the Oracle workload. Generally, what you see in a database like that, there are some setups where in the database or even in some applications where you configure your heap size to say 4 gigabytes of RAM. DM is not necessarily like if you're configuring static memory inside the guest, but then you have dynamic memory at the host, your dynamic memory needs to be larger than whatever static memory you're configuring for an app, plus a little bit more. So for that example, let's say you've got static memory defined inside an application or database of 4 gigabytes. What you might want to do is set your DM to run between 4 and 6, and that way if some other thing that you're running on the machine needs memory, it can get it, but you're not still over-provisioning above and beyond what your app is. We also saw this with SQL. If you have multiple SQL instances, for example, you've got 4 SQL instances on a machine that has 8 gigabytes of RAM, but all of those are set to just grow infinitely, they'll start fighting with each other. So in a case like that, you do want to go in and statically cap some of your instances within SQL Server, but then in the overall realm of what your machine gets, you can still set that dynamically. And there's actually some best practices and guidance that the SQL team has worked on around some things like that. So that's what I wanted to mention on.
Something else that's important to know is that the reason why they've configured dynamic memory to page inside the guest instead of page at the host level is because the virtual machine is much more aware of the workloads that it's running at any given point. So the idea is that the virtual machine, running whatever workload it's trying to run, is more able to make best use of its memory. So when it does a hot add operation or is starved of memory, it's better able to prioritize the workloads within that virtual machine. Something else that's been noted is that, hey, if you're trying to install an application and your hot add memory operation hasn't gone and grabbed additional memory from the host for that virtual machine, your application may say, hey, you don't have enough memory to install this app. That's something where we found, okay, we got to temporarily up that startup memory so that way we're able to actually install that application. But after that occurs, the memory conditions within the virtual machine will typically allow the memory to expand and contract as necessary.
Cluster shared volumes, or CSVs. So how many people out there right now have cluster shared volumes deployed in their environment? Okay, great. Cluster shared volumes allowed users to use a lot less LUNs when managing Hyper-V. You go back into the old days of pre-R2, you had 1 VM per LUN. So when you start to cluster, what you'll find really quickly is that if you're doing 1 VM per LUN and you really only get 22 drive letters to work with, it's a very short matter of time before you run out of drive letters. And so the workaround for that was, well, you will refer to your disks by their volume GUID whenever you need to hit them through Explorer or in any other manner, and you would do that by going to whack, whack, question, whack, and a string of like 30 characters that you could never type, you only could copy and paste. So cluster shared volume, one of the main things, one of the many things that it did was it allowed you to use a single namespace, a single place that you could put all of your machines through the sort of the virtual equivalent of a mount point that sat at C:cluster storage. And you could put unlimited LUNs there and then store all your virtual machines in that one spot. The other thing that you could do with cluster shared volumes is that now you can actually have multiple virtual machines live on the same disk and use the same LUN. So you move away from a 1 VM per LUN scenario. It enabled a lot of things and allowed you to dramatically do better things with your Hyper-V clustering environment. However, it had some gotchas here and there. So one of the main gotchas that it had is that one is that it dramatically complicated backups. So the way CSV works, we're not going to go into the whole depth of that. There are lots of presentations on that. I would look for anything that Eldon Christensen presents around cluster shared volumes to learn more about that. But what's basically happening is that multiple servers are using the same LUN simultaneously. So if you have a 5-node cluster, one node owns that disk primarily, and it's known as the coordinator node. All of the other nodes in the cluster are using that disk, but they're not the official owner of the disk. Well, there are certain operations that you need to perform that only the coordinator node can perform, such as growing a file, anything that required a metadata change, or in one of these cases, backups. Backups, the coordinator node had to put a lock on. And so when you get into certain states, you'd go into something called redirected I/O mode, and the specific case around that was primarily around backups when it came out. And so that provided some pain points. But there are a few different ways that you can work around a few of these pain points. One of them that we'll mention here is the next to last bullet point. When using cluster shared volumes, be sure to transfer files to and from the coordinator node. The reason for that is, as I mentioned, when a particular file write is occurring, if you say you have server 1 and server 2, server 1 owns this disk, but you copy the file to server 2, you're actually having to make an extra hop to write that file. Likewise with backups, if you have a VM that's being backed up on server 2, but server 1 owns the disk, you've actually once again got to go through an extra hop. There were a few ways around that, which was that in certain cases what you would do is, for example, if you wanted to do a set of virtual machine backups, you could put all the VMs on the same node as the cluster shared volume beforehand, or you could just line up all your VMs specifically with a given CSV. And then when that occurs, because that node owns all the VMs that are on the same disk, you don't see those same hits. Some of that stuff exists exactly as it stood the day that it shipped. Some of the stuff has gotten better, but it all gets dramatically better in Windows 2012, and we'll actually talk about that in the next slide. But one other thing we want to mention here is CSV sizing. When you're using CSVs, a question is, well, if I can put multiple VMs on a CSV, how many VMs should I put on a CSV? There is no necessarily right answer to that. It all depends a lot on your environment, on what kind of storage you're using, what your requirements are, what you need to have from visibility into a given set of workloads. For example, if you put 50 virtual machines on a given CSV and you start to see some sort of major I/O spikes or latency around a given CSV, the more stuff you have on it, the harder it is to peg down, and you can go in and do those things with perfmon. But as you start to get more and more virtual machines across more and more disks, figuring out where the source problem is increases in complexity. So sometimes, for example, if you might see a SAN alert saying CSV3 is running at 40 milliseconds latency and it's running 300 megabytes a second, you've got to go in and try and sort out where that is. If you have a few VMs, it's easier. You can just eyeball it. Otherwise, you're going to have to actually go in and do some digging. Virtual Machine Manager actually helps a lot there because it actually gives you a view in the console of the I/O of any given machine at any given time. But that's one of the items to be aware of. A second is, as we talked about, backups. If you end up with a lot of virtual machines and you do want to, for some reason, actually line up the virtual machines with a host, if you put 45 VMs on a CSV, but you can only put 20 on a host, there's never any way you could consolidate if you got in a situation where you would want to. Primarily what we've decided to do in general is we usually put 10 to 15 VMs on a CSV, or the number of VMs that a general host could manage, which in our case a lot of time is around 15 VMs per host, and we find that we have minimal issues with that. If you, we just anecdotally, when we first started with this deployment, we went 1 VM per CSV because we wanted to have the visibility of what it looked like, and we actually did find that when you scale it to several hundred CSVs in a node, you can very small changes in your environment that may introduce a few milliseconds of weirdness can dramatically expand. So we found that having 300 CSVs in a cluster when you could only have five managed much more efficiently than 300. So that's sort of the model that we've rested in. But the thing that I would say around that is test, validate, benchmark, and form your own opinion when it comes to CSVs. However, in 2012, most of the things that you've had to worry about that we've just been discussing, they pretty much go away. One of the big things that I was specifically happy to see is the AD authentication dependencies are gone. One of the reasons why we would see weirdness sometimes in cluster shared volumes is because they actually had to do auth, just like traditional standard SMB auth. If a server A needed to access the cluster shared volume on server B, it had to call into Active Directory to get permission to do so. And if there was any latency to the DC, or if the DC went down for any reason, then server A couldn't access server B anymore. So we would run into weird situations where, since our DCs weren't in the same place, if that link to DC went down or got some sort of firewall blip or any number of things, the CSV would start acting a little crazy. So one of the great things in 2012 is they actually took all AD dependencies out. So now all the cluster, or all the nodes in the cluster access the CSV using computer accounts, local accounts, and they do all their auth within themselves. So all of those weird issues we used to see where latency would cause the CSV to do weird things, those have gone away. The other thing is there's a lot more direct I/O. The whole model of redirected I/O around doing things like writing a file or doing the backup, they've eliminated those. So there are still cases where I/O has to redirect, but there are a lot less of those cases. And now, so for example, you can do a file copy to whatever node. You don't have to go in and figure out where the coordinator node is living at that moment. They also take advantage of SMB multi-channel, part of the new SMB set, where if you have multiple links, you can actually run that I/O across multiple links. So CSV just, in summary, is dramatically improved in 2012. We're actually part of the Windows HAP deployment and have been using CSV in production in 2012 and have been just overwhelmingly positively excited about everything that it's done. So I was a critic at times of cluster shared volumes over the past few years, but in 2012 I love it. I have nothing bad to say about it. The one other thing that I'd mention is the CSV block cache is a new feature. It enables certain scenarios to be optimized where you have a lot of read, or you want a block of read cache. One example is, say, VDI, where you want to have a gold VHD and have it readily accessible. CSV adds a new feature called CSV block cache that allows all the nodes in the cluster to hit that particular set of cache. I would encourage you to, if you want to read more about that, if you think you might hit a scenario, some new articles just came out on that, either on TechNet or the Windows Server blog. I'm sure if you do a web search for CSV block cache, you'll come across that.
All right, we're going to talk a little bit about virtual machine performance, some of the gaps that we've seen in certain ways of implementing, and we're also going to talk about how that's changed in Server 2008 R2, or excuse me, in 2012. What we've typically found is that in our Windows 2008 R2 implementations is we've gone with a scale-out VM strategy. And that's tended to be a general best practice regardless of hypervisor platform or regardless of your typical approach to VMs, because scaling out tends to allow us to isolate our resources. So we try to keep our virtual machines down to the smallest number of cores possible. Typically, we start with 2, simply because that's a good model for us to be able to isolate those resources rather than immediately giving someone 4 when they ask for it. We also really feel that that's a good scalability model because it allows for us, especially with the automations that I'm going to demo a little later, to be able to easily add nodes to our production environments. Whereas instead of having simply a scale-up model, it allows me to scale out the appropriate resources necessary for us to serve that workload. It also allows us to optimize our storage usage and hardware by purchasing SAN hardware that allows us to grow modularly as well. We also have found that if you starve your hosts of memory, that's a big problem. You need to be very careful about that. Something we found very valuable for performance is to make sure that your guest networking is completely isolated. We go in and do quite a few analyses of companies' Hyper-V implementations, and something that we've seen quite often is that people have shared their guest networking with their management hosts, or they're sharing their guest networking with their storage networking. And that's a real big mistake because that creates that virtual network that sits above those 2 networks. And especially in this particular version, it creates a lot of confusion for people because they're not super aware of how that virtual network relates to that physical hardware. So we always recommend that you isolate your guest networks from your storage networks, from your live migration networks, from your management networks. Those 4 things should always be different. And we talk a little bit about that in networking. We've also found that although the market originally had a good price point around multiple 1 gigabit connections using MPIO for storage, we found that we've started to go much more with 10 gig E. And that's been a great simplifier for us because we've needed far less individual network cards in our servers. And it's been something that we've been able to gain quite a bit of performance from. Also, something that's relevant to this is when you're configuring your network cards, although there are performance assets in offloading technologies, we tend to always disable offloading. One of the things that I see the most on the forums is people who have been trying to use offloading and been causing problems for themselves. So we tend to disable RSS, any of the TCP or UDP offloading settings. I'd say that's the #1 troubleshooting solution that we find on the forums, is that people have that enabled. And as soon as they disable that, they're going to find that those sort of funny performance issues tend to go away. So that's something that you guys should definitely keep in mind.
I wanted to mention on the don't starve your host of memory point, just so you have some more context of what that can mean. In general, Windows has an algorithm around, I'm sorry, I'll grab that question. Has an algorithm around memory in the parent partition and how much should stay there. And normally it works, but there are cases where it may not work because you may have other things in the parent partition. And obviously, best practice is you don't want to put other things in the parent partition, except there are a bunch of things that you need in the parent partition, such as a SCOM agent, an ops manager agent, a VMM agent, possibly a DPM agent, antivirus, your open manage tool, for example, if it's a Dell server. And when you put those 7, 8, 9 things sitting in the parent partition, that's using more memory than a generic out-of-box config. So it's times like that when you may run into a need where, especially if you start trying to push DM and server consolidation to where you end up with a place where pressure is actually being applied at the host level. Let's say you have 64 gigs of RAM on a host. With 60 running, it runs fine. But as you start pushing 65 gig of demand onto that, something has to give. The VMs are going to start compressing at the DM level, but at some level, the parents are also going to be starting to get pushed. And that's where that reserve comes in. The reserve generally only is going to come in if you have extreme pressure on the host. And it's at times like that when that setting might need to be altered. And that's actually some registry settings that you can go in and change, and you can also do a search on that. But if you are putting other things on your Hyper-V host, I would encourage you to check that part out.
So what's changed in Windows 8? Windows 8 has dramatically increased scalability of virtual machines within the context of your clusters or in your standalone systems. What that doesn't change is the inherent best practice of scale out. Tends to be a great model to use. However, at this point, we can practically virtualize any workload. And that's awesome. It means that I can put 32 virtual machines, 32 virtual processors inside of a VM. You can put 1 terabyte of memory inside of a VM. We have guest NUMA. So we have a lot of capabilities inside the context of the virtual machines themselves. That certainly allowed us to be able to have these very, very large VMs, such as SQL servers or Exchange servers, inside the context of our VM environment that are running in production with Windows 8. Something that I would make sure I comment about is that sometimes people are a little confused about how CPU scheduling works inside the context of Hyper-V. CPUs in the current version of Hyper-V, as well as in Windows 8, are independently scheduled. So they're not scheduled as blocks. So if you said, hey, I want to apply 8 CPUs or 4 CPUs to my individual virtual machines, it's not scheduled in this entire 4 CPU block. They're each individually scheduled for your workloads. So just because you've increased the number of CPUs doesn't mean that it's going to be time slicing at a rate where you're saying, I'm waiting for all 4 of those to be able to, quote, spin up the CPU to be able to deal with my workload. They're all individually scheduled. So in those cases of very large workloads, you're not going to gain a negative performance impact when you're scaling to those 8 CPUs or 16 CPUs for that SQL server, when its utilization is running at a small level and then spikes. You do have an opportunity to be able to have those CPUs allocated when you need to have that performance burstability. All right. Something we're also going to talk a little bit about is replication and cross-site failover. Replication in the current R2 product is something where we have a couple of different options that we've implemented. The first of these is what we call SAN replication, right? So SAN replication demands a very low transit time between your sites. It demands very high bandwidth, and you have to stretch your VLAN. So that allows for us to be able to have what we call like a stretch cluster between 2 disparate locations. It's something we've had a lot of success with, but it's something that serves very specific customer sets. If you need to be able to survive the loss of that whole site, and you want high availability between those 2 locations, a cross-site cluster, or say a geo cluster, allows for you to be able to achieve that, and it allows you to achieve it reliably. But there's a lot of validation that has to go into that configuration process. So on the SAN side, at the network side, at the offloading side, everything has to be set up very effectively for you to be successful with that, because the transit time is very important. There are some alternatives to that. There's something called host-based replication, where there's some third-party tools. The downside is that that tends to be relatively expensive. And then what we've also used is we've used DPM for backup-based replication. Why have we used that? We've used that because a lot of people have these high availability clusters in their main locations that they're using to serve their 100, 1,000, 5,000, whatever virtual machines. And they want to be able to have those protected. They want to have them protected at a known good state, and they want them off-site. So DPM tends to be a very good solution for that, because it allows for us to be able to back up the virtual machines in a crash-consistent state with a VSS shadow, and then we also allows us then to replicate those virtual machines to a failover location. That's been very helpful for both branch offices, consolidating back to a main site, as well as from 2 data centers replicating to each other. So we've seen that to be a very good option for us. Now, this leads to what I think is probably my favorite feature in Windows 2012, which is Hyper-V Replica. Hyper-V Replica is not a replacement for clustering. So clustering is still just as relevant today as it was tomorrow, and it is something that allows us to achieve high availability inside the context of our operations environments. Hyper-V Replica is a failover technology, and it's an awesome one, but it's not an instant failover, right? So its job is to take your virtual machines that are running in your production workload and replicate those to a failover location. It could be inside the same site. It can't be inside the cluster, right? It's between a cluster or a single host to another target, be it a cluster or another single host. And the idea behind that is you may have 2 potentially separate entire networks, not sharing an IP space, not sharing a VLAN, still replicating between those 2 locations, individual virtual machines. What's neat about it is you can literally replicate just one virtual machine if that's the workload that you want to have replicated to the failover site. Or you could replicate all the virtual machines in your cluster over to the failover site. And that's something that is done on a per virtual machine basis, and also allows for you to be able to monitor it with Operations Manager, and also allows for you to keep previous versions of the replicated virtual machine at the failover location. So when it's replicating and you have something happen to that virtual machine at the main site, let's say someone accidentally deletes a whole bunch of files and takes out the virtual machine, right? You don't want to go back to last night's DPM backup. You want to go back to, say, 30 minutes ago. Well, Hyper-V Replica allows for me to turn on that virtual machine, failover of that virtual machine at the failover site to that state of, say, 30 minutes ago. And I then configure the number of additional recovery points that are at that failover site that are available to me to be able to use. It also allows for me to be able to have smaller implementations that aren't necessarily clustered, that replicate to each other for high availability. That's very useful for perhaps branch offices where the workloads are important enough that you want to be able to protect them, but you may not have shared storage. So there's a lot of benefits that come along with Hyper-V Replica in that space as well. I can show you just a quick overview demo here of what Hyper-V Replica looks like. This is an example. Well, this is one of my virtual servers at Concurrency. And you can see that I'm running Hyper-V Replica from my Cincy RDGW10, which is a remote desktop gateway server. I can see that my primary server is Cincy vSphere 20, and my replica server is Cincy vSphere 22. Now, when I configure this, I first start by configuring it on a host level. So at the host, I go into my Hyper-V settings, and I look at my replica configuration. And I can see that my replica configuration is configured to run over a specific port. So I choose that port. It could be 80, could be 8080, whatever it is. This is really appropriate for only internal environments, right? This is an insecure replication mechanism in this case. If I were to choose port 443 and use the certificate, that would allow me to replicate to my alternative location, my failover location, through a secure connection. And also would facilitate me replicating perhaps to even a third-party partner, someone that has a replica server that I don't even own, that I'm paying a subscription fee to over the internet that I could replicate to. So that model provides me a lot of options for my failover disaster recovery options. I can select also, when it comes to receiving replication, who I will receive replication from. So I can say allow replication from any authenticated server or allow replication from just specific servers. That's very useful if you're not necessarily trusting who's configuring Hyper-V Replica in your environment and you want to protect your clusters, or you want to try to set up a topology that says you're only replicating this particular hub and spoke model. Now, in the context of my Hyper-V Replica configuration, I can always go and see the health, right? So I can say view replication health, and this is going to allow me to understand whether or not my replication is healthy, whether or not it's been replicating in a consistent basis, what its size replication has been, what the maximum size was. You can see 9.6 gig. The reason it says that is because I just seeded this initially before we came in the room, right? And I can also understand whether or not I've encountered errors and whether or not my replication cycles have been achieved successfully. So, for example, if it's replicating and I shut down the other box, I might see that I have a failed replication cycle. What's really cool is it will actually understand where it left off and restart. And I found that to be a really nice feature within the Hyper-V Replica feature set.
I just wanted to go ahead and mention that we are probably going to run right to the end or possibly a few minutes over, but we are going to be available for Q&A as well. We actually have a Q&A session here. We're probably going to want to have to go back to the slides here. Sorry.
Yeah, awesome.
Again, we're going to be available for more questions if we don't make it all the way to the end. So.
Go ahead.
I'll take networking. I don't remember. I'll take networking. So networking, best practices. As we mentioned before, you always want to isolate your networks, guest networking, your live migration network. Primarily, there are a couple of reasons. One, for security reasons, though probably the bigger reason is for just performance reasons. You could run into some collisions as you start to share between management and guests. There are ways where the guest network could overtake your management network and cause issues at that level. So you always want to have really a minimum of 4 sets of networks. And in general, 10 gig makes things dramatically better. When you're running these things over a 1 gig NIC, especially around doing things like live migration, the 10 gig NIC versus the 1 gig NIC, primarily the two places where you're going to see 10 gig dramatically change things are live migration and storage. And as we go into 2012, by the way, before I go to the next slide, I just want to go ahead and mention this bullet real quick. In Windows 2008 R2, if you're ever editing a VM's network in network properties, so if you go into the VM properties and change the NIC setting, always do that if you're clustered from failover cluster manager, not from Hyper-V manager. The reason for that is because there's actually an XML file that lives, the VM config, that gets shared between servers, and when you change that from Hyper-V, it doesn't automatically refresh that across all the nodes. So what will happen is if you try and live migrate and you edit it from Hyper-V, it will throw an error and the VM actually won't move. So that's one of those fun things that's fixed in Windows 2012. In Windows 2012, they require you to make that edit from the failover cluster manager as opposed to the Hyper-V server.
Something to watch out here too when we're talking about MPIO is if you're using iSCSI and you're doing MPIO, make sure to do your MPIO connections either using the out-of-box hit or using the SAN provider's hit kit, or preferably what we do is we prefer to use our own script-driven connection method, and that's very useful because we were talking about how if you ever updated drivers, sometimes that can screw with the locations of the networks on the hosts and cause your host to be able to redetect the network cards. What we found is that if we take the time to be able to build a script to do all the iSCSI connections, A, it's a lot faster because we don't have to individually click for them all, but B, it allows us to easily rebuild our iSCSI connections if we ever needed to make modifications to our drivers.
So we're going to have to move along quickly. 2012, the huge change. I think his favorite feature was replica. One of my favorites is LBFO and NIC teaming. Historically, we've never generally gone through and implemented the third-party NIC teaming solutions just because we usually have personally steered clear of third-party solutions when we didn't have to go to third-party solutions. We've been thrilled with using LBFO NIC teaming in Windows 2012. The idea is that it's totally vendor independent. You can team Broadcom NICs, you can team Intel NICs, you can team whatever NICs you want, and you can do it via the GUI, via Server Manager, or via PowerShell. It's very simple, and it allows you to put together multiple sets of network cards to, especially when you're looking at 10 gig cards, to dramatically simplify your environment. If you can just put together a couple 10 gig NICs and then carve out all of those other networks you needed. So the previous slide we talked about isolating all your networks. With QoS that comes in networking in Windows 2012, along with NIC teaming, you actually can fudge that requirement a little bit more and start merging some of those networks back together because you have so much bandwidth through load balancing and failover, especially across 10 gig NICs, that you can then use a Hyper-V vSwitch and carve out multiple vNICs, including vNICs inside the parent partition. So you can just team at the LBFO level and let the parent partition use those, or you can also team those, hook it up to a vSwitch, and actually allow the management partition to get its own VLAN NICs through that vSwitch, which the amount of things that you can do once you get all of these tools, the possibilities are nearly endless. So I'd say test that, play with that. This feature has been a lot of fun, especially if you've got some 10 gig NICs in your environment. You want to touch on the other features there?
Something I really want to note about is something called consistent device naming. One of the things we spend a lot of time with in our implementations of Hyper-V is tracing cables to the switch and then to the SAN device and then labeling where they go and documenting it all. And that's very valuable, but it's something that I wish I didn't have to do. And that's particularly challenging because when you start up and install your Windows OS, it detects those network cards in kind of any direction that it feels like detecting them in. So it'll show up as NIC 1, 2, 3, and 4. Well, you don't know if 1, 2, 3, and 4 is at what side of the network card, right? So we start by plug, unplug, plug, unplug, and that's really annoying. Well, consistent device naming allows us to be able to have the hardware vendor tag it as NIC red 1, and then when you install the OS, it shows up as NIC red 1. So we actually already know which particular network card port aligns with the particular detected network card that's within the host, and that allows us to save a lot of time. Also, a feature in here that's I think is really useful for some of my clients is SRIOV. The point of that particular capability is to provide more direct I/O to the network stack for network applications that you might have that require very, very low latency, where your application is very dependent upon having instant network hardware accessibility, and that millisecond difference actually means something to you. That's where SRIOV is going to provide a drastic change in terms of how that hardware is accessed by that virtual machine. The thing to note is that that cannot be used in conjunction with teaming. So those NICs are typically dedicated to that usage. There's also a slew of new vSwitch features. So they've implemented a much more componentized and much more capable vSwitch infrastructure in terms of Hyper-V. And that allows us to have network taps. It allows us to have protection around different types of ARP poisoning and such that we would have occur inside of our Hyper-V environments. And that's a great opportunity that we have. That network tap port mirroring, I think, is something I'm really excited about, seeing partners come out with integrations for. You can actually use the typical sniffing tools as well in conjunction with that. Import-export
is something I'll go over really quickly. the gist of it is that in Windows 2008 R2, the way of exporting VMs is generally, if you're doing it through the GUI, is that you're going to dump an entire full copy of the virtual machine to another folder. So you have a VM that you've shut down and you want to export it somewhere. You go through the UI and you export it. You'll just do a full file copy of the XML files that go with that VM in addition to the VHDs. That uses a lot of time and space. So there's a way around that. You can do config-only export. Config-only export is available through scripting, and the scripts are not intuitive. It's not something you will be able to just go out to the command line and figure out how to do a config-only export. In fact, it might be impossible unless you were a developer or knew something about that space. But you can go out to the web and you can find some example scripts. In fact, Ben Armstrong has posted an example script on that. I think Taylor Brown's posted an example script on that. And you can find links to that in the scripting section that we go a little bit later. But if you do a config-only export and a config-only import, you're still going to run into some catches. There's a good chance. If you're wanting to do an export of a VM and move it to another server, and then import it on that other server, the things you're going to find with those export imports is that especially if you're doing the config, is that your network name on the other side, unless it's totally 100% identical, which is very unlikely, or your storage path, unless the storage path is 100% identical, what's going to happen is the VM is going to throw an error during the import time. So you actually have to go in and hand clean up your XML if you want to do that import on the other side. So in general, 9 times out of 10, it's going to be easier to just copy the VHDs without the XML and just recreate the VM on the other side. So what happens if you create the VM on the other side with just from scratch? The one downside to that, assuming you've documented everything, the one downside to that is when you launch the operating system and log in, you're going to see that it detected a brand new network card. So if you were using either a MAC reservation for DHCP or if you had a static IP address, that server is no longer going to have the IP that it had. So what you'll have to do is actually give that server back its old IP. So, and still it ends up being easier rather than go through the export-import process. It's a lot faster. So what we actually ended up doing when we were doing a set of mass migrations is we just took a NetSH script that we ran inside the guest that dumped its config pre-copy over to the desktop, and then when we started the VM up on the other side, we just ran that import and brought it right back in with those same NetSH settings. So import-export gets a lot better in Windows 2012. It's radically improved. The big thing is that you don't need to have an export file anymore to do an import. That was the biggest problem with R2, is you could never import a VM unless you previously exported it, and you never knew that you needed to export it until it was too late. So now you can just take any given virtual machine that you've got sitting anywhere, just import it in place. And it works amazingly well. So the same catches that you had in the old days, if the storage didn't line up or if the NIC didn't line up, now if you run this through the wizard, it actually says, hey, I noticed this network card's not there. Which one do you want to pick? You can choose it from the drop-down. And then it says, what folder were your VHDs stored in? You choose that from a drop-down, you next finish, and you're done. And you don't have to export at all. You just take that VM, register it in place. You can set it with a new ID or use an existing one using register. You can also now do this via PowerShell. You can do this without the crazy WMI that you would have had to have done previously. You actually just have import-VM and you have compare-VM. So the purpose of compare-VM is to generate the compat report. Because I talked about if you do this through the GUI, you've got the wizard you follow. PowerShell, you're not going to have a wizard, right? So what you can do is you say $report equals compare VM, and it will tell you, it will actually run what that wizard would have run, and it'll say, oh, this storage wasn't lined up. Well, then you can run a commandlet to say attach the VHD at this spot, or change the VHD location, and you can also say connect-network adapter and bring that in. So you can actually 100% automate. If you're doing a migration between two sets of virtual machine or two sets of hypervisors, you can automate that entire thing with PowerShell with just a few lines. It's been a great change. Live migration. For those of you that have used 2008 R2, I'm sure if you've clustered at all, you've used live migration. The one tip to this that you might not know if just you were an initial user is that you can actually change network priority. You can change network priority of your CSV and of live migration. However, in live migration, it's kind of hard to find. You would think because you're setting it at the entire server level, you would make this setting somewhere in your Hyper-V server settings, but it's not there. In fact, it's actually inside the VM properties under the Network for Live Migration tab. You can go up and down and set whatever live migration network you want to set it on. That's the main thing I wanted to mention specifically that might catch you. You also have the tip there that you want to enable jumbo frames for dramatically improved performance. And the third one there is disable file sharing and cluster usage on the live migration network. And 2012, what's new in live migration? The biggest thing around 2012 live migration is you can do as many live migrations at one time as you want. By default, it comes out of the box with simultaneous live migrations of 2. You can crank that up to 10 to 15, as we mentioned, depending on what your storage is. I've got a team 10 gig on here, and I can set this to 10 or so, 10 or 15, and actually just hit a drain on a node and have the entire node evacuated in about 10 seconds. 10 seconds or less, I can dump an entire 80 gigs of VMs of RAM over to the other side. It's an amazing thing to behold when you start seeing concurrent live migration across team 10 gig NICs. Anyone that's seen that demo, it's an impressive demo. The other big thing is shared nothing live migration. You don't need to even be in a cluster anymore to live migrate. You can live migrate between 2 separate hosts. You can do that if you're using shared storage with Hyper-V over SMB, or you can do it actually with 2 servers that are using just locally attached disks. You could have just an iOmega drive if they still have those on your server, and you could copy from one server to another server live without bringing the machine offline. Again, same thing, make sure to enable jumbo frames. Storage. There's a few things we want to mention with storage. In this case, we're primarily talking about the context of snapshots and checkpoints. This is one that probably bites more people that are new to Hyper-V than any other thing on the planet, is if they go through and start setting snapshots and checkpoints on a machine that inevitably they run out of disk space and cause their entire environment to crash. So what happens is snapshots and checkpoints, first of all, are the same thing, except Hyper-V refers to them as snapshots and Virtual Machine Manager refers to them as checkpoints. It may change down there, but that's the way things have been historically. So when you use one of those, what happens is you basically take a point-in-time snapshot of a virtual machine, and then you have an AVHD file which keeps all your deltas in it. That thing's going to grow indefinitely and keep growing and growing and growing unless you ever reverted back or merged those. Inevitably, at some point, if you have a lot of things on a disk and you're not watching your storage, you're going to fill up that disk. So you can use snapshots. We use snapshots, but when you use them in production, you've got to know some key things. One is that they're temporary. They're not there forever. You either need to be reverting back or merging. And when you're merging, you have to power off the VM to merge. And if you've let it run for a really long time before you merge it, it could be down for hours, it could be minutes, it could be hours, it could be days. It depends on how long. So if you can never power off that VM for a day, you may be stuck. You may be in a really bad situation. So make sure that when you are using them that you, again, will merge them, that you're using them temporarily. If you just need to check something, you're going to do an upgrade. You make that snap, you make the changes, everything's good, you don't need to roll back, you re-merge it. The second thing to be aware of there is Active Directory passwords with a computer account. This applies to restoring a backup from DPM or anything where you're reverting. Passwords change in Active Directory every so many days depending on your policy. And what happens is if you take a snapshot and then a month later you revert your machine, it's going to have a different computer account password most likely. And what will happen is it won't be able to hit the DC. So you have to unjoin it from the domain and rejoin it to the domain. So you can actually change a setting within Windows that doesn't allow your Active Directory password to change. So if you're going to be actually using snapshots and reverting those snapshots, you want to be aware of that you don't want to be fighting around the password changes. And I think we will roll forward since we're about 2/3 through the deck. Best practices, dynamic disks. So dynamic disks is one I want to make sure to touch on. We have differing opinions on dynamic disks depending on who you talk to. But personally, my opinion on dynamic disks is that we find that for 80 to 90% of workloads, they work fine and they provide us a lot of savings, especially when paired with a thin provision storage. You can actually spin up a disk that's 128 gigabytes that is using 7 gigabytes times 100 times 1,000, and you don't have to go out and buy an exabyte of storage. You can just let that storage grow over time. There's a few caveats to that. One specifically being that if you have workloads that you know are going to be about one size, and they are a workload where you need high performance, especially if you have a database line and you know the database is always going to be a particular size, it's something where in that case you might want to use a fixed VHD. But the main takeaway that I want to give you is that there is no right answer that you should always use dynamic disks, and there's no right answer that you should always use fixed disks. We actually use about 90% of all the machines in our production deployments are on dynamic VHDs because, again, the storage savings that you can get on that can be dramatic. Now, if you think that over time this thing is only ever going to get up to 40 gigs and you just want to spend that 40 gigs to begin with, that's all well and good. But just be aware that this is one of the biggest costs of your virtualization environment is the storage. And this is a way that you can get a lot of savings if you don't need all of that perf. Now, that being said, there's about a 10% hit right off the bat. Dynamic VHDs are going to perform a 10% less than a fixed VHD through white papers and other things. And there are other cases where a dynamic VHD, when you hit into certain situations, when a dynamic VHD needs to grow, for example, on a CSV, where a dynamic VHD would require a lock for the moment that it's growing. So if you have 100 dynamic VHDs on a CSV, and those all need to grow at the same moment, you're actually going to hit a lock where some of those are going to take some time. So you could actually hit a perf issue in that. That's a very rare circumstance. Let's say you're going to spin up 100 new VMs at once and try and apply a whole bunch of patches to them. You would hit a state where your performance is going to tank. But over time, assuming especially if you're only putting like 10 VMs on a LUN, you shouldn't see that kind of issue. There are a couple articles I would point you to. I've got a case on my blog that talks about the case why I use them. Aidan Finn, I'll go ahead and call out. He's another virtualization MVP, and he's written a blog post on why he doesn't like to use them. So you can read both of them and form your own opinion. The other thing that's I'd mention here is that in 2012, all the things we talked about around snapshots and merging, how you have to power off that VM for days, that's gone away. You can actually let your VHD and your AVHD merge live in Windows 2012. So possibly if you had that workload that we talked about that you left on and now you've got a terabyte of AVHDs, you might be able to bring that over and merge them over here online. Live migration of storage is another feature that's new in 2012. We talked about the export-import thing. What you can actually do here is live migrate storage from one server to another server. You can actually, within the same server, if you copied a VHD to a place you didn't want to have in the long term, or you wanted to put it on a different CSV, because maybe you didn't scale the CSVs the way you wanted to, you can actually do that live through the Hyper-V wizard. You can put the storage somewhere else without powering off the VM. We've got 64 terabyte VHDXs and other general great perf things there. Dramatically reduced check this time, but we are running out of time, so we're going to press on.
Awesome.
Guest clustering, do you want to take it, or do you want me to take it?
Why don't you take it?
Okay. So in Windows 2008 R2, if you wanted to do guest clustering, you don't really have a lot of options. You're going to do iSCSI for guest clustering because that's really the only way that you could get shared disks within your guests. So what that means is if you're going to do guest clustering, you need a lot of networks. We already talked about needing 4 networks to begin with. Once you start needing iSCSI networks, if you want to run MPIO across your guest, that's 2 more networks. If you're running MPIO at your host, that's a lot of NICs. So in the end, we've generally, especially unless we have a lot of servers with a lot of network cards, we've avoided guest clustering if we could find a way to not do guest clustering. Windows 2012 makes that a little bit better because they added synthetic fiber channel. There's a screenshot of synthetic fiber channel here. What you can define is if you're using fiber channel storage, that would be one requirement. You can actually set up with MPIV fiber channel inside your guest VMs now, and you can run that across a clustered host. And with that, you can now have guest clustering using synthetic fiber channel. The other thing you can do is you can now use LBFO, like we talked about with those 10 gig teams, and you can carve out iSCSI networks where you would have normally needed a lot more NICs. You can actually set up your own guest iSCSI VLANs, or that's much more flexible. So guest clustering becomes easier in 2012 with those primary 2 enhancements. Scripting. Windows 2008 R2, scripting, there's a few ways you could do it. You could either use WMI, like the top example of get WMI object MSVM computer system, and get a WMI object inside the root virtualization namespace. Those are pretty difficult scripts to write, and that's why there are lots of community scripts that you can go out and gather. In general, you don't want to write a WMI script for Hyper-V unless you have a lot of time and a great desire to perform an act that you can't do some other way. And it's possible that you can go out to this community script site that's referenced here in the deck, and there's 100 examples of something where somebody's already written that for you. Your other option is the Hyper-V module that was published on Codeplex some time ago. It makes a wrapper to all this WMI that makes it much, much easier to use. And the last option is you can use VMM. VMM gives you all of these command lists to do just about anything in Hyper-V that you would want to do that would require WMI up at that top layer. In 2012, this gets dramatically better. All the stuff that you needed third-party stuff to do, whether it was VMM or Codeplex or something, they're all in box now. You can run basic commands like new VM, get VM, set VM, start VM, stop VM, import VM. Everything is straightforward. They're easy to use. I've been a big fan of these commandlets. I've got an example on my blog of how you would run a scripting workflow in Windows 2012. And here's just an example of what it looks like. If you want to make a new VM, you can set the new VM with the VM path to the cluster storage, the switch you want it on, your dynamic memory minimum, maximum bytes. Those are your top two lines. If you want to set your VM to a separate VLAN, you can set that on the third line. If you want to cluster it, that's the fourth line. That was much, much more complicated before. And if you've tried to do it in earlier versions, you really appreciate how well scripting has come along in Windows 2012. System Center.
Awesome. One of the things that you've probably seen already today is that you have the opportunity to be able to use System Center, specifically Service Manager and Orchestrator in conjunction with your virtual machine provisioning. That's something that you can use with the Cloud Accelerator pack to be able to have an individual or an IT member go out to a self-service site and do provisioning of the individual virtual machines that they like based upon available resources that are available to them specifically, as well as the ability to be able to set specific templates that you offer them. This is great for build-back. It's great for flexible resources. It's great for abstracting your virtual environment from the people who are requesting the resources. So a lot of the scripting complexities that can exist inside of trying to do it manually, you can push into a self-service portal to allow for your individuals who are kind of your moderate IT users who are requesting virtual machines that you need to approve. You can push those through a self-service portal that is used in conjunction with Service Manager and Orchestrator to actually perform the virtual machine provisioning through Virtual Machine Manager. So you have an awesome set of capabilities available in that.
So we actually had some demos prepared, but because we are 1 minute over, I'm going to go to the next slide and invite anybody that wants to see the demos to hang around, and you can see the demos with us. We're also going to be doing the Q&A. We have a Q&A set at 5:30 in it's not the ComNet Lounge, but the area over there. There's a speaker Q&A set up, and we'll be there. We've also got a lot more information, a lot more tips and tricks on our blog. And as far as questions, we're going to hold those for the Q&A that's getting ready to start. So with that, I would like to thank you very much for coming to our session. Hope you have a great rest of the week. Also,